Okay, we're going to go over the chemical versus physical notes. So we're going to look at chemical and physical properties first, and then chemical and physical changes. All right, so a property is a characteristic or a trait that you can use to describe matter by observation and or measurement. So basically, we're just looking at something to describe a substance when we're talking about a property. Physical properties are properties that you think of on a normal basis. When you look at something and you want to describe it, it's probably a physical property. A physical property is something that can be observed or measured without changing the identity of the matter. A chemical property is something that you actually have to see how it reacts. So it usually involves some sort of a chemical change in order to observe a chemical property. So it's how something reacts with other substances. Physical properties are things that we have already learned about the elements on our periodic table. So malleability, ductility, luster, conductivity are all physical properties. Also just general characteristics that you would use to describe something, like its size, mass, volume, density, shape, smell, color, and also the temperature at which something melts, freezes, or boils would be considered a physical property. Chemical properties are our reaction properties. So its ability to do something or tendency to do something is a chemical property. So the ability to burn, which is referred to as either as flammability or combustibility, would be a chemical property. Its reactions with oxygen, typically called oxidation reactions, are pretty important kinds of reactions in chemistry. Reactions with living things, so like is something toxic or corrosive to a living thing, its reaction with other chemicals, and that's just called reactivity. pH happens to be a one way to measure reactivity and a chemical property. Okay, so now we have physical and chemical changes. So if we have a physical change, we do not have changes to the properties of a substance. It might look a little bit different than it did before, but we don't have anything new. So the example here is a lemon that you slice into lemon slices is still a lemon. And a chemical change does create a new substance with new chemical and physical properties. So when you take a log and you burn it, it doesn't look like a log anymore. It doesn't feel like a log. It doesn't have the same density as the log did before. In addition to that, the ashes aren't going to burn like the original log did. So they have both different chemical and physical properties after a chemical reaction has occurred. These are just some basic examples of different physical and chemical changes. So on the left, our physical changes are melting ice, chopping wood, mixing gray and green marbles, and shredding paper. So all of these things are pretty easy to identify as maybe looking different after we change them, but essentially holding the same properties as they did before. Chemical changes that we're familiar with include burning anything, not just wood, rotting banana, mixing vinegar and baking soda, which we did last week, and fireworks. So all of these things are a chemical reaction has occurred and new products have been formed. So on an atomic level, what that means is that the atoms don't change their arrangements. So if we have atomic bonds, so like in water, we have H2O. If we go from liquid water to water vapor, or from liquid water to ice, solid water, we're still going to have water atoms. So H's, two H's bonded to an O. We're just changing how close together or far apart they are. So it changes the way they look, but not the chemical composition. However, in a chemical reaction, we're actually changing bonds here. It requires more energy. And so here there's three main types of reactions, chemical reactions. You can either combine things, you can switch things, or you can break things down. So here we have some purples combining with blues. Here we have blacks and whites and reds, and here we have a black bonded with red and a reds blended with whites. And here we have two large molecules that are broken into two smaller molecules with some of the reds left over. So these are called synthesis, replacement, and decomposition reactions. You don't really need to know that. What you do need to know is that when we have a chemical change, we have a change in bonds. So we're either building something, rearranging something, or breaking something down. All right, so let's look at physical change first. So evidence of a physical change would involve something that might look a little bit different, but essentially isn't different from the original material, okay? So if we are changing the state of matter, so we are adding or taking heat away actively, introducing something to that, then we have changing them from a solid to a liquid, or a liquid to a solid, or a liquid to a gas. Then that's a state change. We can change things in size just by cutting them, breaking them, stretching them out, changing their shape by folding them, scrunching them together, stretching them, those types of things. And then, of course, mixtures, which we've already learned about, can be homogeneous or heterogeneous. Sometimes it's really easy to tell that it's a physical change, like when you put tomatoes and lettuce together, they're not chemically bonding in a salad. But sometimes it's a little bit more difficult, like when we looked at our Gatorade mixture. But no matter what, they're all still the same substance. So some examples of some physical change. Here we have some size and shape changes. We have splitting wood, cutting a log into smaller pieces. We have wadding up a blanket. Some examples of state changes. So here we have a bowl of once frozen ice cream, now kind of melted ice cream. Here we have water frozen into an ice cube tray. And then here we have this physical change of a solution. Remember, that's our homogeneous mixture. So a solution involves what we call a solute, the thing that is mixed into the liquid, typically that separates it out. So we have most of the drinks that we think of, flavored drinks, are solutions, which are typically mostly water with something dissolved in that. But that's still, again, just a physical change, just a really evenly mixed mixture. Okay, so let's look at our chemical changes now. For our chemical changes, we are looking at some things that you wouldn't normally expect. So an unexpected color change, an unexpected temperature change, an unexpected new substance, the production of light, or a change of odor. So what I mean by an unexpected color change, if you have something that is blue and you mix it with something that is yellow, then if you get something that's green, that is an expected color change because that's a normal color combination change. However, if you take something blue and you mix it with something yellow and it turns red, then that is an unexpected color change. Or usually what you have is like two clear things that are mixed together and all of a sudden you have this wacky color. So that's what we're talking about with unexpected color change. Unexpected temperature change would be like last week when we did not introduce a substance to a cooler or warmer environment, and it's still, when we mixed these things together, all of a sudden there was a temperature change. So like on Friday when our baking soda and vinegar all of a sudden dropped temperature and became cooler. So those are some different examples, okay? color changes that are kind of some typical examples of chemical change would be rusting or tarnishing. So that's just when a metal interacts with the oxygen in the air and has a chemical reaction. That's called rusting or tarnishing, depending upon the metal. And then we can have some kind of, more exciting chemical reactions that involve color changes with solutions and things like that. One type of chemical change that you're going to need to be familiar with is called a precipitate. A precipitate is when you take two liquids and you mix them together and a solid forms. So again, we're not changing the temperature, we're just this would be like a room temperature reaction, and you mix them together and all of a sudden it's usually kind of like a powdery solid that forms in the solution. So these are two examples. Here we have a yellow precipitate that has formed from two clear solutions, and here we have kind of a light blue solution and a clear solution that forms a dark blue precipitate. So precipitate is the solid that forms spontaneously when two liquids are combined. Other chemical changes can be just general life processes. So here, photosynthesis is a chemical reaction. You probably already knew this even though you didn't think about it, because you have carbon dioxide and water that are coming into the plant with the energy from the sun. They are converted into sugar and oxygen, two totally different compounds. So that's definitely a chemical change. Digestion involves a series of both physical and chemical changes, but most of the chemical changes occur in your stomach and your small intestine, where different acids and enzymes are introduced to your food, and they break those large pieces of food into the small sugars and things that make them up so that you can absorb them into your body. And then down here is a really kind of nasty GIF of a mouse, dead little mouse decomposing. And so that also involves a series of chemical changes and chemical reactions. All right, so let's see what you can do. Have you been listening to the notes? And can you identify each of these 6 changes as either being a chemical or a physical change? Rotting food. Creating a solution. Taking a hammer and flattening out the piece of gold. So has the gold gone through a chemical or a physical change? Photosynthesis. Water changing from liquid to water vapor, either through evaporation or through speed evaporation when we boil it. And finally, when your stomach acid breaks down your food.